Okay, this one's called 5.3, day 2. We're going to use more properties of exponents to solve equations. And by the end of the hour, I want to make sure that you know how to do the base change thing that we learned first. I want to remind you about how those extraneous and missing solutions work. And I want to make sure that you're good at using those exponent properties. All right, here's one. Right off the bat, this one's tough because you think 4 to the 1/3 power? I have no idea what that is. So instead, just multiply those two powers, because that's what happens if you have a power to a power. It's just a multiply problem. So do this on your iPad right now or on your piece of paper, which works too. It's going to be 4 to the something. Once you simplify that thing down, it'll be much more understandable. Staring off into space with a quizzical look is not good enough. Write this down with a new exponent, 4 to the something. Do you get how this becomes 9 over 6? So it's really 4 to the 9/6, but that's really 4 to the, 3 goes in here, 3 over 2, 4 to the 3 over 2, and then that should be easy. Show me what you think it is. All right, I'm getting lots of interesting answers here. I think some people are confused about whether you have plus or minus in there or not. I want everybody to look at that for just a second. I want you to think about this. This is just a number. A number. You take the square root of a number. Does it ever come out negative? It's only if I had done this to both sides. It's the variable side that if you ever take a square root of a variable, that's when you get two answers, plus and minus. So some of you are overthinking the problem. It's not plus and minus. It's just 8. Okay? Because again, if I had done square root on both sides, I did the square root to it. If I did that, then the variable would have been square rooted, and that's what causes the two answer thing. All right, let's move on. This one, x to the 2/3 equals 64. Now you should ask yourself, why isn't it already solved? X is kind of alone. It's got an exponent issue. So all right, you should have been putting it to the 3/2. To the 3/2. And this cancels, that cancels, and that's x equals x to the 1. Yay! And then square root of 64 is 8. And that's a little bit of a pain. 8 to the 3rd? 512. Raise your hand if you had 512. Raise your hand if you know you're wrong. Plus and minus 512. What just happened? We did the square root on both sides. If we do the square root of a variable, which we did, plus and minus. I know, that's confusing. That's why when I teach in the pre-calc class and I have the same question kind of thing come up on a test 5 times, some kids get it wrong 5 times in a row, like 5 separate tests, because they keep forgetting. It's so easy to forget. Try not to, though. If you ever take a square root on both sides, and even root, like that. All right. Yes? Yep, if you do a cube root, it does not matter. Let me show you why. Just a second. Just a second. Say I have an 8 in here, and I do the cube root of 8. Cube root of 8 is just 2. Would you agree with that? Okay. Cube root of -8. Does that cause a problem like square roots? No. Cube roots are okay with negatives inside. Okay, so bottom line is, if you ever do a power like this to both sides, and that's a 2 on the bottom, or a 4, or a 6, or an 8, you getting it? Every even number power is the one you have to watch out for. Okay, moving on. This one, everybody get to this one, please. Solve it. This is one I would expect you to be able to do in your head. X to the 2/3 equals 8 plus 8 is 16. Then put that to the 3/2 power, and then x is equal to, that cancels. 16 to 1/2 is the square root of 16. Square root of 16 is 4. 4 to the 3rd is 64. Who's got a better answer than that? Ooh, a bunch of people, because it's plus and minus 64. Why? Because we did a square root on both sides. Any even root. I'm trying to pound it into your head, because it's just, even though it's only a half of a point and it happens only a few times, you know, that could be like 7% off on your test just for getting that one dumb little thing. And as you move into pre-calc, they start teaching with Marzano style testing, meaning that it's right or wrong. So you forget something like that, whole problem's wrong. Like, you don't just get half off, you lose the whole thing. So it becomes more and more important as you move on. Okay, remember this base change thing? If both the bases were at 2, it would be much better, because then when both bases are the same, the exponents have to be the same. Well, this one's got 2 issues. It doesn't have any exponent on the right, and the base is not 2. Go ahead and fix that. Make it so that on the right side, the base is 2. By now, I'm hoping these are like, okay, that's easy. I got this kind down. Mr. H, front row, tell me what to do.
We're going to do 2 to the -4.
Perfect. 2 to the -4th. The negative makes it a fraction. The 4th makes it up to 16. Okay. Now what?
And then do 4x equals...
Perfect. X equals -1. Raise your hand if you had that one right. Awesome. This one. Got to do a little simplifying. Whenever you're in a math problem, if you can simplify it, you should simplify it. Factoring sometimes simplifies things, but in this case, we just want to like make these happy, get them up there to join with the other x's, take the 4 and the 8, simplify them a little bit. Final answer would end up being x to the 5th over 2y. There, I simplified it. Now, next rule in math, if you can get rid of the fractions, you should. Can I get rid of that fraction there on the left? Multiply by what? And multiply by 2i on both sides. Cancels. X to the 5th equals 2y. Then you want to get the x alone. What's not right about it? The 5 power. And then how do you fix that? Put it to the 1/5. Did I just do a square root? No, because that's an odd root. So x is equal to, that I wouldn't even expect you to be able to do, so therefore you leave it as this. Unless anybody knows what the 5th root of 2 is in their head, it's probably like 1.372 or whatever. Yes, sir? No, I think you're thinking of negative. If it had a negative power, you'd do that. This is just a fraction power. That means root. They want the 5th root, and I don't know what the 5th root of 2 is, and I don't know what the 5th root of y is. All right, let's move on. This one, a lot like the last one. Now that we practiced one, should go easy peasy lemon squeezy. So fun to say. Kind of like Francisco. Can I get the movie reference on that? What movie? Elf. Mr. G, tell me how you simplified the left-hand side. You can give me a little less detail. What did the top give you? And what did you get on the bottom? Excellent. And then did you simplify more? Good, because you can't. All right, I thought you could, but I realized you couldn't. All right, So what do you think?
What I did is that 2 over 1 is equal to 2.
Can't argue with that. 2 over 1 is equal to 2.
And then cross.
Oh, I see. Okay, so you're saying like make this into over 1 and then cross multiply them. Yes, absolutely, that would work. But the calc teachers want me to teach you this way, and it is good, I have to admit, it's pretty good. You can just always say this simple thing. Instead of having to try to remember the whole make a fraction, cross multiply, that is cool, I like it. But there's an easier way. Is there a fraction in my problem? Clear the fraction. So how do I clear the fraction? Multiply by 9y to the 8th. And that'll do the same thing you just said. It's just a way that they want us to have you know how to do. And if you'd have done it that other way, they'd have been totally happy as long as you show your work. Okay, this. Now I'm going to divide by 2. Could I multiply that out and make it an 18? Yeah, but I don't even need to, because as soon as I divide by 2 right here, divide by 2, divide by 2, those are going to cancel and those are going to cancel. See? X squared equals 9y to the 8th. I'm really close. Now, how do I finish this deal? How do I fix the x squared? Square root. Square root. Absolute value of x. That'll keep me from forgetting my plus minus. And what's the square root of 9? 3. What's the square root of y to the 8th? Y to the 4th. A lot of people wouldn't have known that. Let me think that through with you for just a second. Square root of y to the 8th means, it means what times what would make y to the 8th. And y to the 4th times y to the 4th does make y to the 8th, so the answer is y to the 4th. Okay. Here's another sneaky way you could have done this one. Plus and minus 3y to the 4th. Why did I do the plus and minus? Because it was an absolute value. Why was it an absolute value? Because I did a square root on both sides. Okay, and the variable has a square root. The other sneaky way you could figure out the square root of, let's say, y to the 16th is to go like this. That means that's y to a fraction power. And remember how the roots are on the bottom? Which root is this? Root 2. And what's the other number that we put it to? The 16th. And then if I simplify that, do you get that the answer is y to the 8th? So what if I had this? X to the 3rd power, 4th root. What now? X to the what? False. The roots are always on the bottom. You like your carrots this way? The roots are on the bottom. So what's on the bottom? Make sense? The roots are on the bottom. Okay, how about this one? 5x to the negative 3rd, square root of that. Whoo-wee! Now what? Actually, wait. Sorry. There we go. Now it'll work. Try it. Just try it. I changed the problem, by the way. It's 25x underneath the root. I know somebody didn't change it yet. Mr. L, tell me what to do. Just give me part of it.
Well, you could put the root be -3.
Nope. The root is this part.
Oh, it's the other.
Okay. Just tell me what to do. Okay. How about this? Simplify it down to just that part.
Square 25 is 5.
There you go. So I can just put a 5. And now I can say that the other part is x to the something. X to the something. And then the roots are always on the bottom, so the roots are on the bottom, so there's a 2 on the bottom. And then what's left to put on the top? There you go. All right. Stretching you a little bit there. Hope I didn't break any of you. All right. Try that one. Do you get that that one's to the 4th root? Gotta fix that. Let me guess, it was Easter at your house recently. Oh, okay. People giving out food to try to convince people to vote for them? Gotcha. Does it work? Behold the power of food. All right, in the back corner, tell me what you did. Did you do something to both sides? That's what I would have done. You're right. And that makes this x equals 16. Now, here's the tougher question. Would negative 16 work also? Plug it back into the original problem. Would negative 16 be okay to have right there? Square root of negative 16 is not okay, not if it's an even root. Did I square root both sides? No. I squared, or in this case, put to the fourth power. If I had done this to both sides, that'd be different. Then I would do the plus and minus thing. But putting something to the fourth power doesn't cause multiple answers. The other way I can tell that it's not going to work, I mean, if I had this one, this is the simplest of them all. I keep going back to this one. The answers are 4 and negative 4, right? Why? Because if you put the negative 4 back in, it works. Go back to this one. If I put in a negative 16 right here, that's not going to work. I have a square root of a negative. That's not allowed. Okay. The other reason I know is because it's only if I do roots on both sides. That's not a root. That's just to the fourth power. That's not a root. All right, moving on to this kind. But try that one. We're going fast, which is good, because then that means you can have more time to work on your homework. Did you start by subtracting 2 from both sides? I hope so. You should have this. Subtract 2, negative 1. I'm going to pause for a second. Okay. Next, would you agree that this part right here is actually to the 1/3 power right now? I need to cube it to fix that. That's just another way to think of that. But cube root and cubed are kind of the opposite of each other, like Superman and Kryptonite. They kind of take each other out. All right. X minus 2 equals negative 1. There we go. I know that was a flawed analogy because Superman is taken out by Kryptonite, but Kryptonite is not taken out by Superman. Anyway, adding 2 to both sides, x is equal to 1. Raise your hand if you got the same thing. Okay, excellent. You're all wrong. Did I warn you about profiling the guy with the big baggy coat? This is the guy with the big baggy coat. Because I have... Oh, wait a minute. No, I'm wrong, but at least you didn't even think about it. Okay, I'm wrong. If I put this back in here, you get how it's got a 1 minus 2, which makes a negative underneath the root. But why isn't this particular one a problem? Because it's a cube root. And cube roots can have negatives underneath them. Like I can do the cube root of negative 8, and it's just negative 2. If this had been squared, though, the entire earth starts to tremble and shake, and the whole thing comes crashing down. All right, so anyway, that one was 1, but you should have thought about going back and put it in because you should profile these problems that have roots in them to make sure you don't, by accident, give an answer that doesn't work that's called extraneous. Okay, try this one. Give you a hint. If they had the same base on both sides, then you could just set the exponents equal to each other. Wait a minute, they do have the same base. Kind of. Sort of. I need another piece of paper. Oh, okay. Tell me what you did.
Well, if the x is 8, then it reduces down to 1. So
You're right.
if you make a 9 on the top, and you have...
All right, so you just kind of reasoned it out. And that works. 2 to the 9th over 2 to the 8th would be just 2 to the 1, and that would be right. Okay, so you reasoned it out, and you're right. The answer is 9. Okay, let's follow it through here. If you were going to do it the right way, the way I would expect you to make it, I would want you to make the bases equal to each other. And they'd both have a base of 2. So this is 2 to the 1, and this is 2 to the what? 2 to the what? Come on, you can do this. X minus 8 equals 2 to the 1. Now you get how it's a little more normal setup, and now you could just say that has to equal that. X minus 8 equals 1, and so you're right. Add 8, x equals 9. Your way of guessing and checking happened to work well this time, but if the decimals are nasty, just know how to do it that way, because it's not always going to work out so nice in your head. All right, try that one. Just a quick reminder here that you do have a top 20 due by Friday. It was version 5 on your iPad. If you haven't already got that puppy done, get it done. All right, you should have said this is 2 to the negative x plus 8. Getting a little weird there. And that 4 should be written as a 2 to the second. That way they have the same base. That way this equals that. Negative x plus 8 equals 2. Subtract 8. Negative x equals negative 6. X must equal positive 6. Should I profile this one to double check it? No, but I could if I wanted to. Don't have to though, because it's probably not a terrorist. Okay, so this 6, I'm going to put this right here, is going to make it 2 to the second, and 2 to the second is equal to 4. Yay! Okay. I'm surprised terrorists haven't gotten into like big sporting events like the Super Bowl or whatever. Did you know that at the Super Bowl they had like 4 snipers set up the entire game? Or built into the building, they have sniper areas where the snipers can sit and have their guns trained on the audience with like rounds in the chamber ready to go. Isn't that kind of scary? You're sitting in a place where there's snipers looking through their scope at the field the whole time, or at the people in the stands, because they're afraid that there's some sniper or some bad guy going to be, they're going to notice this bad guy who's got, heaven forbid, a vest on that's like explosives or whatever. I don't know how they would get in, but I saw a pretty convincing episode of, what was it? Burn Notice, I think, where they had, or maybe it was something else. Anyway, they had this a way that a terrorist could get through a metal detector. They described how they could make a vest out of little ceramic pellets. Anybody see this episode I'm talking about? One of those kind of spy shows. Anyway, if you think about it, if you had vests made out of ceramic pellets, it would be like impossible. It wouldn't pick up on the metal detectors. And ceramic is like hard as steel. So basically, all you need is some kind of a gel explosive and these ceramic pellets, and somebody could walk in. Again, that's why they frisk people with big heavy coats on, because they can't detect everything with a metal detector. So anyway, there's also fear that they can make plastic guns now with, have you heard of 3D printing? And they can make a 3D printing of guns. They can actually make functional guns with a 3D printer. I know it seems just insane, like how is that even possible? But I've seen stuff made by 3D printers, and they can have like moving parts. I don't get how they do that, but they could do it. So if you can make a plastic gun now, and actually they can, they have outlawed the plans for it. But of course, just because you've outlawed the plans doesn't mean the bad guys can't get them. So all kinds of reasons I'm glad we have people in our country that are trying to protect us from the bad guys. That's their full-time job, is trying to make sure to figure out ways to stop people like that. All right, hopefully you have squared both sides. And here's the problem. Some of you are going to have said, oh, x squared plus 4, because I squared this and I squared that. Do you remember that that's not the right way to do it? When you square something like this, you've got to do FOIL. Know what I mean? It's really easy to forget that. So this side becomes first x squared, outside and inside plus 4x lasts plus 4. And then you've got a quadratic. Been a while. I need a snappy rhyme for this. You always set quadratics to 0. Then you see if they can factor. And if they can't factor, then you need to do the quadratic formula. Now, I don't have a good rhyme for it, but that's the process. You always go through the quadratic. Set it equals 0, see if it'll factor, use quadratic formula. Subtract x, subtract x. Everybody do that. Set it equal to 0, see if you can factor it. You should be able to factor it. This one's like easy level, if you're talking video games. Novice. And I'm going to subtract 4 from both sides. And this becomes 0 equals x squared minus 3x. Just, I know it's not a normal one, but just see if it'll factor. So 0 equals x, and then what? Sorry. X, and then what? X plus 3. Get what just happened there? I just factored this. And now that it's factored, do you get there's two answers? The one that makes this part 0, which would be what? -3, and what makes that part 0? 0. So 0 works, and -3 works. And if you wanted to check it, oops, -3 is that one, and 0 is this one. If you wanted to check -3 and 0, you go back up here, put in -3. Why did I check this one? Yep, you got it. Let's get the big coat. All right. So that one, let's see if it's working though. Does -3 actually work? Because I end up with square root of 1 equals -3 plus 2. Did that work? What's the square root of 1? What's -3 plus 2? No, one of them's 1 and the other one's -1. Are 1 and -1 actually equal to each other? Holy cow, we just found one that was extraneous. Wasn't it a good thing we checked? You'd lost half a point on that one. Half a points add up. I think on this next test, every half a point you lose is like 3.5%. So 2 half points, you lost 7%. All right. How about the 0? Does the 0 actually work? Well, let me check. See if 0 works. You already check it? Okay. I'll double check it. 0, 0. That's square root of 4 equals 2. It worked. Yes. Okay. Okay, so one of them worked, one of them didn't. Easy mistake to make. Yes? Okay, so what you do is when you cross this off, you say extraneous. You say that -3 is extraneous answer. It's an answer that doesn't work, kind of like the finger I was telling you about the other day, the poker player. Did I tell you about that? Yes. So you want only the functional fingers, or the functional answers. Last one. Give this one a shot. Square both sides. See what happens. Happens a lot in pre-calc. We get extraneous answers. You do all the work. Actually, in pre-calc, it's especially painful because seriously, sometimes problems are like 10 minutes long, and you finally reach the end, and you get the answer of 6, and if you forget to go check it, a lot of times it doesn't even work after all of that work. Got an answer that's extraneous. Now when you square, last time some of you guys thought that the negative would still be there. It is not. You square a negative, like if I have -6 and I square it, it'll be positive 36. The negative here will be gone. So I end up with x minus 2 equals 2x plus 1. From there, it should be pretty easy. So I'm going to subtract x. -2 equals x plus 1. Then I'm going to subtract 1. Negative 3 equals x. Now, should I check it? Is this the kind of problem I should check? It is. Negative 3. I better check. Negative 3. Oh, negative 3 minus 2 makes negative 5. I have the square root of negative 5. Is that allowed ever? Anywhere? No. Even if the other side comes out to negative square root of negative 5. That's like saying 2 wrongs make a right. They don't. Yes, it's true the other side ends up being square root of negative 5. But even if they're the same, it's not okay. It's sort of like some guy is standing in the park and he is allowed to have the freedom of speech, right? He can say whatever he wants. True? Okay. Can he say that the president is a terrible person? Yes. Can he threaten to kill the president? No. Now he's crossed the line. Not allowed. They can throw you in jail for that. So even if you're kind of doing something that you're allowed to do, you can cross the line. This, if you have a negative underneath the square root, instant go to jail. All right. Any other things you want to ask me? Okay, so we already graded homework in this hour, and I'm going to be getting those scores from you later. And the homework for tonight, I'll probably grade another one because I don't have many in the grade book yet, so I want to start cranking them up. So keep doing your homework. I'll get you an iPad so you can copy the problems out of my iPad. And that's all I have for the video for today.